All right, ninth assignment of alkyl and aryl halides. First is nomenclature. This is orthobromone. Then this is CH, CH3, CH2, CH3. This is the structure of the molecule. You can see this is butane chain. At butane, at say carbon number 2 of butane, phenyl group is attached. At 1 dash, 2 dash, at 2 dash carbon atom of phenyl, bromo is attached, right? So I can say this is butane. On the second carbon of butane, phenyl is attached. At carbon number 2 dash of phenyl, bromo is attached. So IUPAC name is 2 within brackets 2 dash bromophenyl butane. Second, CH3, CH3, CH2, CH2Br. This is the longest chain and direction of counting. IUPAC name is 1 bromo 3 methyl butane, and this can be, yes, this one is aryl halide, and second example is primary alkyl halide. Primary alkyl halide. Third example, CCl3, CCl3 and chlorine and CCl3. This is straight chain of 3 carbon atoms. That is propane. It has a lengthy IUPAC name. I'll dictate you if you can write. 3 carbon atom chain, that is propane. This is 1, 1, 1, 2, 3, 3, 3. I'll repeat 1, 1, 1, 2, 3, 3, 3, heptachloro. After that, we'll name this part. After heptachloro, 2, this will be trichloromethyl propane. I'll repeat complete IUPAC name 1, 1, 1, 2, 3, 3, 3, heptachloro, 2 within brackets trichloromethyl propane. Now coming to fill in the blanks. Propylene is the common name for propene. Propene with HBr OP. This will be anti-Martinic of addition. 1 bromopropane. With ammonia, this is Hoffman's ammonolysis, gives propanamine, that is primary amine. This reacts with chloroform alcoholic OH heat. This is carbylamine test, leads to the formation of isocyanide. Second sequence. Normal propylidine chloride. Normal propylidine chloride is nothing but the common name of 1,1-dichloropropane. 1,1-dichloropropane with alcoholic KOH. This is double dehydrogenation, will lead to formation of alkyne. Alkyne with HCl excess, follow Markovnikov's rule, you'll get 2,2-dichloropropane. This is reactive with aqueous KOH. This is NSR. Both chlorine atoms will be replaced by OH groups. 2 OH on the same carbon will be unstable, will lose water, and ultimately product obtained will be a ketone, that is CH3COCH3. I'll explain here. Both chlorine atoms will be replaced by OH groups. 2 OH on the same carbon will be unstable. This will lose a molecule of water. After losing water, ketone will be formed. Now, next reaction is with bromine NaOH. Now, you can see here, this product has, propanone has required group for the preparation of chloroform, bromoform, or iodoform. So when this is reacted with bromine NaOH, this carbon will change into bromoform CHBr3, and the second product will be sodium acetate. This carbon does not change. This carbon will change into COONA, sodium acetate. Third sequence. We proceed in the reverse direction. Last, we are given normal propyl isocyanide, and this is prepared by carbalamine test. It means C is normal propyl amine. Amine is obtained by the reaction of B with ammonia. It means this is one halopropane. What is halogen? We don't know. This is one halopropane. Now, as we proceed further, B is prepared by the reaction of A with Ki phosphoric acid. This is in situ preparation of PI3. PI3 attacks alcohol to give iodo product. It means A is one propanol, B is one iodopropane. Fourth sequence. 2-bromobutane with alcoholic OH, dehydrogenation, and you'll follow Sazaf rule. Product obtained will be 2-butene. 2-butene with chlorine CCl4, vicinal dihalide will be formed. 2,3-dichlorobutane is obtained. Alcoholic OH, double dehydrogenation will take place, will get 2-butyne. HCl excess, add according to Markovnikov rule, product obtained will be 2,2-dichlorobutane. Aqueous KOH, NSR will take place, 2 halogen replaced by 2 OH minus water, as I told you earlier. This will lead to the formation of a ketone. This is the product obtained. Now this is E. This is reacted with iodine and NaOH. You can see this is the required group for iodoform test. This carbon will change into iodoform, and this will not change. This will change into COONA, sodium propanoate. Iodoform and sodium propanoate are last two products. Explain why. All answers will find in notes. What happens when benzene diazoyl chloride is heated with HCl in the presence of cuprous chloride? Sandmeyer's reaction takes place to give chlorobenzene. You'll write balanced chemical equation and write in words as well. Next, toluene is reacted with chlorine in the presence of aluminum chloride in the dark. Chlorination takes place on the aromatic ring to give a mixture of ortho and para toluene chloride. Again, equation. Chloroform is heated with aqueous NaOH. NSR takes place to give formic acid. Even this reaction you'll find in notes. Distinguish between ethylamine and diethylamine. This you'll find in notes also. You can distinguish by using isocyanide carbalamine test. Ethylamine will lead to the formation of false smelling isocyanide. Diethylamine will not. Second, methanol and ethanol. You can see in ethanol, there is required group for the formation of iodoform. So react both the compounds with iodine and NaOH. No yellow crystalline solid obtained in the first case. Ethanol reacts and leads to the formation of yellow crystalline solid iodoform, and you have to write the balanced chemical equation for the reaction of ethanol with iodine and NaOH. Now, conversions. Isopropyl chloride into dinormal propyl ether. One of the NSRs you'll find that ether is obtained, ether is prepared by Williamson synthesis. For Williamson synthesis, reactants are RX and RONA. Chains are same. So this is RX and this is RONA. These two will react and give final product. This is 2-halopropane. we have to convert 2 halopropane into 1 halopropane. Naturally, we'll go via alkene stage. This is alcoholic KOH dehydrohalogenation, and this is reacted with HBr peroxide anti-Markovnikov addition and will lead to the formation of 1-bromopropane. As I told you earlier, those reactions which have been used many times, I'll not be writing reagents again and again. Second conversion. Ethylidene chloride into ethylene chloride. Ethylene chloride is vicinal, ethylidene chloride is geminal. When you want to prepare vicinal dihalide, react alkene with halogen. This reaction you have used in fill in the blanks many times. Alkene with chlorine in the presence of CCl4 solvent, you'll get the final product. You have to convert 1,1-dichloropropane into this. React with alcoholic KOH. This is dehydrohalogenation. Now, how to convert alkyne into alkene? You studied the reaction in 11th standard. That is controlled hydrogenation by using Lindlar's catalyst. This you will have to remember. So hydrogen in the presence of Lindlar's catalyst. Even if you do not remember what is Lindlar's catalyst, is okay. But name at least you should know. Otherwise, Lindlar's catalyst is palladium adsorbed on the surface of charcoal, which is poisoned by using barium sulfate. But anyways, you can write Lindlar's catalyst. Third conversion, propyne into iodoform. React with HX According to Markovnikov, you'll get 2,2-dihalopropane. React with aqueous NaOH or aqueous KOH. We use this reaction many times today in fill in the blanks. You'll get a ketone. React with iodine NaOH. You'll get iodoform. Benzene into para-chloronitrobenzene. Benzene into para-chloronitrobenzene. Chlorination in the presence of catalyst cold and dark. You'll get chlorobenzene. React with the nitrating mixture, you'll get the final product. Both reactions you'll find in notes. Isobutyl alcohol into tertiary chloride. You can convert alcohol into alkyl halide. You have studied many methods. Alkyl halide into alkene, dehydrohalogenation by using alcoholic KOH. Add HCl. According to Markovnikov's rule, you'll get final product. Last, secondary butyl alcohol into butane. Convert alcohol into alkyl halide by any method you remember. Then reduce alkyl halide into alkane. I told you 3-4 different reducing agents: lithium aluminum hydride, hydrogen catalyst, zinc HCl. Anything can be used for the reduction of alkyl halide into alkane. Next. A branch chain organic dihalide A containing 5 carbon atoms gave B when reacted with aqueous NaOH. B gave positive iodoform test, identify compounds A and B. See, B gives positive iodoform test, it means B should have one of these two groups because B gives positive iodoform test, right? Now, B is obtained by the reaction of A with aqueous NaOH. If B is this, A must contain two halogen on the same carbon. If B is this, then A must be monohalide. It has total 5 carbon atoms and branch chain. It means there should be 3 more carbon atoms with a branch, 3 more carbon atoms with a branch. Same product, same chain will come here. Now there's one more word in the statement, organic dihalide. This is not a dihalide. This is the correct answer. This is the correct answer. So A is this, B is this. Next. Which compound in each of the following pairs will react faster in SN2 reaction with OH minus ions? In SN2, reactivity order will be based on steric hindrance. If steric hindrance is less, reactivity will be more. This is the reason tertiary reacts slowest, primary reacts fastest. First pair, bromomethane and iodomethane. See, both are primary. In this case, you have to think in terms of bond length. So iodomethane will react faster than bromomethane. Second, in second pair, second compound will react faster, which is a primary alkyl halide. First compound given is a tertiary alkyl halide. Third, benzyl chloride and chlorocyclohexane. Benzyl chloride will react faster because this is primary. Chlorocyclohexane is a secondary halide, will react slower. Remember, you will understand these assignments only if you try to solve yourself. Otherwise, it will be just a story, nothing else. Next. We are given some compounds, 1-bromobutane, 1-bromo-2,2-dimethyl propane. Let us say this compound number 2, 1-bromo-2-methyl butane. Compound number 3, 1-bromo-3-methyl butane. We have to arrange them in the increasing reactivity by SN2 reaction. Now, if you look at these structures carefully, all of them are primary. So we cannot arrange them on the basis of primary, secondary, tertiary. All of them are primary. Now you have to think in terms of hindrance around alpha carbon atom. Alpha carbon is the one which carries halogen. See, in this case, hindrance is maximum around alpha carbon. Therefore, reactivity will be least. This will be 2. In this case, there's no hindrance, right? Reactivity of 1 will be maximum. Now, remaining 2. Both have one side chain. This side chain is close to alpha carbon. Therefore, hindrance will be more. This side chain is away from alpha carbon atom. Hindrance will be less. It means reactivity of compound number 4 will be more compared to compound number 3. So this is the order. This is the increasing reactivity of compounds. Next, one more question. Predict all the alkenes that will be obtained by dehydrogenation of following halides and identify the major product. 1-bromo-2-methyl cyclohexane. Now, how many different alkenes are possible? That will depend on hydrogen atoms on beta carbon atoms. Now, this is beta carbon, this is beta carbon, and both carry one, at least one hydrogen. So possible products are these are two possible alkenes formed. This is more symmetrical, therefore this is the major product. Second, 2-chloro-2-methyl butane. 2-chloro-2-methyl butane. Now, alpha hydrogen, carbon which carry alpha hydrogen. This one, and this. These are three beta carbon atoms which carry hydrogen. But these two are equivalent. So we'll consider one of them. Let us say I consider these two. If hydrogen goes from here, double bond will come here. Second possibility, double bond comes here. This is more symmetrical and therefore major product. Third, 2-bromo 2,2,3 trimethyl pentane. 2-bromo 2,2,3 trimethyl. Let me draw skeleton of carbon atoms. Now, beta hydrogen present on these two. There's beta carbon is there. This is beta carbon, but there's no hydrogen on this beta carbon. So possible. Is this the one? Oh, sorry, this is 3-bromo. I'll draw the structure again. 3-bromo 2,2,3. 3-bromo 2,2,3. 3-bromo 2,2,3. Now, beta carbon atoms are this. This is also beta carbon, but there's no hydrogen. If hydrogen goes from there, double bond. If hydrogen goes from here, double bond will come here. This one is definitely more alkylated and more symmetrical. This is the major product, not this. So these are answers of the assignment.